Okay, so this is a supplemental video, and in this supplemental video, what I'd like to do is walk you through a final exam question I asked a few years ago that sort of tries to hit at the heart of what we mean by rate accumulation or by the net change theorem. So in this question, I mean, you can read it. It's not terribly hard to read, really. The important thing to consider in the question, and if you haven't hit pause to read it, you should. This is a rate. How do we know that this is a rate? Because it's measured in centimeters per hour. So we know that we're dealing with a rate. And that sort of sets up the question for us to talk about the amount of water in the ocean rising and falling, depth of the water, et cetera, et cetera. So is the depth of the water increasing or decreasing at noon? Well, time equals 0 is 6 a.m. So noon is time equals 6. I took the liberty of graphing this function for you. This is the graph of R of t. R of t is positive through 6.772, and then R of t is negative till 17.228, and then R of t is positive again. Well, what does that mean? If R of t is positive, then R is in, try that again. If the rate of change is positive, then the quantity being measured is increasing. So the depth of the water is increasing, the depth of the water is decreasing, the depth of the water is increasing. So is the depth of the water increasing or decreasing at time equals 6? Well, R of 6 is, I figured this out, 0.660, which is positive. So the depth is increasing at noon. Because R is positive, the quantity it's measuring is increasing. B part. How much higher will the depth of the water be after a day has passed? After 1 day has passed, how much higher? To the nearest centimeter. Centimeter removes the per hour, so we accomplish this by an integration. Integrate over what interval? Well, a day has passed. That's 24 hours. Now, because this was an exam question, you had your calculator available for this, so you can just integrate this using technology, and you end up with 15.096. So then we answer the question, how much higher to the nearest centimeter? That's 15 centimeters. So then the question is, at what time is the depth of the water at a maximum? So let's take a look at the graph again. The depth of the water is increasing. The depth of the water is decreasing. The depth of the water is increasing. So if there's going to be a max, it's either going to happen here or it's going to happen here. Either the depth is a max here or it's a max here, because the depth goes from increasing to decreasing to increasing. Well, how do we know? How do we know? So we'd have to know how much the water goes down in this interval and how much the water goes up in this interval. Well, how do we figure out how much the water goes down in this interval? We take an integral. We can do that. We can do that on our calculators. If you have an Inspire, you can do it this way. If you don't have an Inspire, we've talked about how to do this in class. This integral value is negative 18.7, which means between this time and this time, the depth of the water goes down by 19 centimeters. Well, how much does it go back up after? It goes up 16.9 centimeters. So the water gets to some local max, and then it goes down by 18.7, and then it comes back up by 16.9. This is not enough to make up for the down. So the max happens at 6.772 hours. That's where the max happens. So we would show that work. We would write all that stuff down, but that's what's happening in that question. 24 hours, there's 6.772 and 17.228, and it's positive 0, negative 0, positive, which means that the depth goes from increasing to decreasing to increasing, and we know that the integral from 6.772 to 17.228 of r of t is negative 18.7, but the integral from 17.228 to 24 of r of t dt, sorry folks, is only 16.9, which is less than 18.7. So the max depth occurs at 6.772. Hopefully this gives you some sort of understanding. As we approach final exam time, we know that something like this is going to happen. As we approach exam time, I have other questions I can share with you about this, but I just wanted to put this out there so that you could see the kinds of things that I expect. Okay.